Okay, ladies and gentlemen, today we begin taking a look at some statistics and how we can view it. Now, the neat thing about statistics is you can see it in so many different aspects of life. So we're going to begin today with the fundamental counting principle. Okay, it says here, daily question: make a tree diagram to see how many different outfits you can wear if you have 3 pairs of pants, 4 shirts, and 2 pairs of shoes. So you have 3 different pairs of pants. All right. And in each of them you have 4 shirts. 1, 2, 3, 4. 1, 2, 3, 4. This is very helpful for those of you that are very visual. And 2 pairs of shoes. Shoes. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 total. 24 different outfits. Okay? Now, you can see how this grows very quickly. Okay, just by drawing a little bit of a picture. What else could I possibly do to figure out how many different outfits there are? Well, today we're going to learn about ways to make this easier. Okay? Because here I had 3, 4, and 2. My next example, I have 195, 99, 89, 105, 74. So how could I come up with 24 based off of these 3 numbers? Well, what you're allowed to do is take your 3 pairs of pants, multiply it by your 4 shirts, and multiply it by 2, your pairs of shoes. 3 times 4 is 12, times 2 gives me 24. Okay? So this just makes our lives way easier. So look at example number 1. Police use photographs of various facial features to help witnesses identify suspects. One basic identification kit contains 195 hairlines, 99 eyes, 89 noses, 105 mouths, 74 chins. How many different combinations of faces can be produced? Well, I take each of these numbers and I multiply them together. So 195 times 99 times 89, 105, 74. So I got my calculator. Okay. And I get a very, very large number. So let's take a look at this. Now this e times e to the 10th means I move this decimal place over 10 spots. So uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different faces. If you guys would like, you may copy it down as you see it here. Just realize that the E stands for times 10 raised to the power of. Okay, something that you're going to see a lot more. Let's continue on. If the witness is sure of the hairline and eyes, how many different faces should be produced? Okay, so that means instead of 195 hairlines, there's 1. Instead of 99 eyes, there's 1. Then I still have 89 noses, 105 mouths, and 74 chins. So this is going to substantially cut it down. Oops. We got 89 times 105 times 74 gives me 691,530 different faces. I know it still seems like a huge number, but compare that to my previous number and you'll realize that that's a really big difference. Okay. Alright, the standard configuration of a New York license plate is 3 digits followed by 3 letters. How many different license plates are possible if digits and letters can be repeated? Alright, so it's 3 and 3, right? So digits is 0 through 9. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's 10 different possibilities for my numbers. 10, 10, 10. There are 26 letters in the alphabet. 26, 26, 26. So what I can do is multiply these all across. It's really tough to see right now, isn't it? That's a little better. Just trying to find the right spot for my calculator. 10 times 10 times 10 times 26 times 26 times 26. So 17,576,000 different license plates. Okay. So it says for part B, how many different license plates are possible if digits and letters cannot be repeated? Well, same setup. Okay. 10, 9, 8. Because what that's saying then is, if I use an example first, like say 9, I can't reuse 9, so now I'm down to only 9 letters left, or 9 numbers left. As far as letters go, you have 26 to begin with, then 25, then 24. Let's see if I can get this to work again. And it is really off today. Okay, so I'm doing 10 times 9 times 8 times 26 times 25 times 24. So that gives me 11 million. Okay, 232,000 different plates. Which makes sense that it would be smaller. Okay. Yes, I know my handwriting is terrible. Alrighty. Cool. Take a look at our back. Okay. Factorial is a number written like this, a number with an exclamation mark right beside it. So here's an example for you guys. Okay, if I said 3 factorial, what that means is it's 3 times 2 times 1. Alright? If I had 7 factorial, it would be 7 times 6 times 5 times 4 times 3 times 2 times 1. It always goes all the way down to 1. Okay? So we have 2 types of things we're going to take a look at. The first is combinations, the number of different possibilities of something happening regardless of order. And permutations, the number of different possibilities of an event occurring where the order of objects matters. Typically you see combinations like, I'm picking 3 books out of a pile, out of a pile of 7. Okay? So there's no real order in terms of which book should I pick first. But permutations is something like, out of 10 people, how many different ways can they finish first, second, third in a race? So this is when order matters. For permutations, order does not matter. Combinations. Okay? So let's take a look here. If there are 12 girls in the softball team, how many different ways could I order the 12 girls? Okay. So in terms of what we could do here is, you have 12 spots. Okay. Now, it's not talking about batting order. Batting order would probably be important, but in this term it's just saying how many different ways can you order them, so there's no real, it doesn't matter what order is. So, for this one, I'm going to do combinations, okay? And I'm going to go ahead and start off with 12 girls for the first spot, followed by 11, followed by 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, I could, if I can get some light on this calculator, maybe possibly. Okay. You can do 12 times all the way down to 1, or you could do 12. There it is. Let me show you again. You type in 12, hit the math button, go all the way to the right for PRB, and the fourth one down is your exclamation mark. That stands for your factorial, and I'll give you your answer. 4, 7, 900, 1600. Okay? Different ways. Alright? But now, for part B, it says if there are 12 girls in the softball team, how many different lineups of 9 girls could the coach make? Alright. Notice before I was making different orders for 12 girls. Here it's only 9. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. My first spot, I have 12 possibilities. Second spot, I have 11. Then 10. Then 9, 8, 7, 6, 5, 4. Okay? So notice that here, okay, I'm missing the 3, 2, 1. So when I'm typing this in, I'm just going 12 times 11 times 10 times 9 times 8, all the way down to 4. So I get 79,833,600 different ways, different lineups. Okay, so that's what we're looking at right there. Now there is a way for this one right here where it says if there are 12 girls in the team, how many different lineups of 9 could they make? This is called a permutation because the lineup matters. Anybody that plays baseball here knows you want to have your best hitter like in the 4th spot and then your cleanup hitter, so on. So on the calculator, if I can figure out a way to show you this because the calculator is just no light today. Maybe. Hang on, I'll be right a second. I'll take it. Okay, you can type in 12, hit the math button, go to the right where it says PRB, and it says NPR. This stands for permutation, and I want to choose 9 different spots. If I hit enter, guess what number pops up? The exact same number here. We will show you guys more of this in class. So it's number first, NPR, second number. Okay, and that is, math button, then PRB, and then it's number 2. Alright, so please copy that down so you're going to see it again. Okay, find the number of distinguishable permutations of the letters in Ohio and Mississippi. So what we can do here is you count how many letters total you have. Alright, 1, 2, 3, 4. I have 4 of them. You put 4 factorial on top. 4 times 3 times 2 times 1. Then what you do is you count how many letters repeat. Okay? So in this case, it's 2. I have 2 O's the same. You put 2 factorial on the bottom if you don't want to repeat. So we got 4 times 3 times 2 times 1 over 2 times 1. Let's see, that's 12, 24 over 2. 12 different ways. Oop, I missed the 12, didn't I? Okay. So part B, I do the same thing. Count how many letters you have in Mississippi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factorial. But now I count the same letters. So I is in there 4 times. I put 4 factorial down low. S is in there 4 times. Put that down low. And P is in there twice. Put that down low. Okay. So how am I going to make this look? Go back to my main screen. It's 11 factorial up top, so I'm going to put parentheses 11 math factorial divided by 4 factorial times 4 factorial times 2 factorial. So I end up with 34,650 different ways to spell. Or not to spell, but to move the letters around. Okay? Very good. So, a lot going on there. Please don't hesitate to ask for any help on any of the calculator work. Okay? I can gladly re-show that. But we're going to try a little bit of practice on the 12.1b worksheet. Okay? So as always, keep up the good work and good luck. We're all counting on you.